Informal statement number 15. We're going to cover a couple informal statements, theorem, and a couple of its corollaries, and we'll be done with this video. Shouldn't take too long. A lot of these informal statements and theorems and corollaries are pretty basic. I'm not even going to formally prove them. If you are in a geometry course that is very rigorous, I'm sorry, I'm not going to prove these. If you are in a rigorous geometry course and you have to prove these, I'm assuming you would easily be able to prove this on your own, and you wouldn't be watching this. So again, very basic ideas. I'm not going to formally prove them. We'll just talk through them, and we'll be done. Informal statement number 15 says, in any polygon, the sum of an exterior angle and the adjacent interior angle equals a straight angle. Again, this is super basic. If we have one exterior angle and we add it to the adjacent interior angle, it will equal a straight angle. Doesn't matter which kind of pair of interior and exterior angle you choose. We've learned that, the sum of the angles about a point on one side of a straight line equals a straight angle. So this is so basic, I'm not even going to waste any more time. So just keep that in mind, though. Informal statement number 16. In any polygon with n sides, actually I'm going to say vertices, with n vertices, the sum of one group of exterior angles and all the interior angles equal n straight angles. Alright, so again, super basic. What it's stating is when you add one group of exterior angles with all the interior angles, you'll get however many vertices there are in that polygon, which literally is what, just adding on to what the previous informal statement was saying. If this exterior angle plus this interior angle equals one straight angle, well, that's going to happen for every single vertex that we have in that polygon. So however many vertices there are in a polygon, if we add all the exterior angles to the interior angles, we'll have that many. So for example, we'll have one straight angle there, one straight angle there, one straight angle there, one straight angle there, and another one there. And we would have 5 straight angles. And so we have 5 vertices, 5 straight angles. So that's what that informal statement is saying. Quick definition here: regular polygon is just a polygon that is equal angular and equilateral. A polygon that is equiangular and equilateral. Pretty simple. All the angles are equal, all the sides are equal. Theorem 26 says that the sum of all the angles of a polygon of n sides is n, the number of sides, minus 2 straight angles. Alright, this is really what it's saying. We could find the number, or how many, the sum, I should say, of all the angles is n minus 2 times 180 degrees, pretty much a straight angle. So, for example, I have a pentagon here, 5 sides, and we just to figure out how many straight angles are in this pentagon, we would do 5n, which is 5n sides is 5 sides in this case, minus 2 straight angles. which would be 3 straight angles. And so pretty basic there. If we wanted to know how many degrees that would be, obviously we'd do 3 times 180. A straight angle is 180, so we'd keep 3 times 180 degrees, and we could figure out the sum of all the interior angles. This is important, minus 2, because obviously when we make these angles here, we can kind of see what's going on. When we create some central angles coming from the vertices, we create triangles. And so there is one straight angle in a triangle. Well, the sum of all the angles in a triangle equals a straight angle. So if we were to add up this, that, and that, it would be one straight angle. And another straight angle, another straight angle, another straight angle, another straight angle. Here we would have 5 straight angles, but that's too many. We ended up with 3 straight angles. We had to subtract 2. It's because we got these extra angles here in the center that is not being accounted for when we divide it into those triangles. We are adding up these central angles when we do that way. But when we subtract the 360 degrees, because we know a paragon is an angle that makes one complete revolution, if we take away those 2 straight angles, a 360 degree angle, then we're left with the rest of these interior angles of the polygon, and that's where we get our 3. We take away the 2 in the middle, and we are told however many straight angles we have in that polygon. Theorem 26. Corollary 26.1 says, in an equiangular polygon of n sides, each angle equals n minus 2 over n straight angles. Okay, so if we were to take even the polygon we just used up here, we see some similarities. We see n minus 2 straight angles, n minus 2, and we see straight angles over here. We know if we multiply by fractions, we're going to end up with n minus 2 straight angles over n. It's the same idea. For example, if we used 5 over 2 times 2, let's just make it super simple. We could divide 5 divided by 2 first and then multiply that by 2. Or we could just say it's the same thing as saying 5 times 2 over 2. It's the same idea. And so if we were to use this quadrilateral here, and obviously there's 4 sides, and so we just figured out how to find the total amount of straight angles in a polygon. So if we had a 4-sided polygon, we would say 4 minus 2 straight angles, and we'd be left with 2 straight angles. Now, if this was a regular polygon where all the angles are equal to each other, then we could easily figure out the size of each of those angles. We could divide it by the number of sides, or in this case, it'd be the number of angles. If there's 4 sides, there's 4 angles here. And so if we had 2 straight angles, we'd have to multiply that, obviously, by 180 instead of saying straight angles. 2 times 180, we'd get obviously 360 degrees, and then we'd divide that by n, which is 4. Each one would be 90 degrees. And so that's the idea. We can simply just do that same thing here. We could do 4 minus 2 over 4 straight angles, and you would get the same exact thing. We would get 2 over 4 straight angles, and then we get 1/2 straight angles, and it will be 1/2 of a straight angle, and so each angle would be 1/2 of a straight angle, or 90 degrees. So pretty simple there. And then last corollary, it states that the sum of the exterior angles of a polygon made by extending each of its sides in succession is equal to 2 straight angles. And now we're just kind of combining all the informal statements and theorems and corollaries we just stated. We figured out that this is 2 straight angles up in here. The central angle is equal to 2 straight angles. We'd have to subtract these 2 straight angles to get the remainder here. We've also said that in some informal statements, the exterior angle plus the adjacent interior angle equals 1 straight angle. So now we're combining those 2 ideas. That now we can state that if we were to add up all the exterior angles of a polygon, doesn't matter how big, or how many sides, I should say, how many sides a polygon has, you'll always get 2 straight angles when you add up the exterior angles of any polygon. It's the same idea that you would always get 360 degrees when you count up the interior angles of a polygon. Just because you get more sides doesn't mean you get more straight angles in the central angles. You're still going to get some of the angles equal to 360 degrees. And the same thing is true about the exterior angles of any polygon. When you add them up, you'll get 2 straight angles or 360 degrees.